So we were talking about the return on investment rate. It's a very important parameter when we assess the economical performance of a project. So as you can see here, we defined, as we said, the rate of return on investment is the rate making the net present value at the end lifetime of the project, yani NPVN. Big N corresponds to the total number of years of the project equal to 0. And in this example, the example we discussed together, the ROI is equal to 3.2. So why it's important to find the ROI? Because we say that for confidence in future, for discount rate higher than the ROI, no profitability. So the first condition to meet in order to have a profitable project is to have the ROI higher than A. Okay. Now we will see another condition to consider that the project is profitable, which is assessed in the CER method, which is called capital enrichment method. So now let us do some analysis on the ROI and the discounted payback period. What is the discounted payback period? The discounted payback period is the period of time needed to reach a net present value of 0. Okay. So for example, let us look at the example we have seen together, and we compared several discount rates 0 to 3.2 and 10. Okay. We said that by definition, the ROI is the discount rate for which the payback period will be equal to the lifetime of the project. So here, for 3.2% as a discount rate, we reach NPV equals 0 for the lifetime of the project. So we can say in this case that the discounted payback period for the discount rate equal to ROI is equal to the lifetime of the system. Okay, because by definition, the ROI is the discount rate that will give us a net present value of 0 at the end of lifetime of the system. Now, if I choose a discount rate lower than 3.2, I can expect a lower discounted payback period. Why? Because, of course, more I have a confidence in future, more I will gain money, okay? And the value of my money will be higher. This is why the amount of time needed to have a balance of 0 will be lower. So as you can see here, if you compare graphs, the blue curve, which corresponds to a lower discount rate than 3.2, which is 2%, the discounted payback period is nearly. So you take the blue curve, you take the line of 0 net present value. It will hit the blue curve here, which corresponds to 15 years. So the payback period dropped from 20 to 15 because of a lower discount rate. Okay, and why we call it discounted payback period? Because this payback period is calculated taking into consideration the confidence in future. Now, guys, can you please mute your microphones? Can you please mute your microphones? So, and if we take a discount rate of 0, okay, this means that we are not considering the confidence in future. Then we call it just payback period, not DPP. DPP is discounted payback period. If we calculate the payback period for 0%, we don't call it discounted then, because we don't have a discount rate, and it's called then payback period. Okay, so if we just ask for the payback period, then we take A equal to 0. And of course, the payback period, which corresponds to A is 0, will be the lowest period, because if we consider that we have a high confidence in future, A is 0, and then the payback period will be low. Okay, so 0% corresponds to the black curve, and the black curve, of course, will give you the lowest payback period, which is nearly 13 years. Okay, and higher is the discount rate. This means that lower is the confidence in future, and higher will be the payback period, the discounted payback period, if you want. And for A higher than 3.2%, what can we say? no discounted payback period. Because if A is higher than 10%, we will never higher than 3.2%, we will never reach a net present value of zero. We need the system to operate for a longer lifetime, and after n years, the system cannot operate anymore. So this is its lifetime. It cannot operate more. So we can say that for A higher than the ROI, okay, then no net present value is lower than zero, and no discounted payback period in this case. Okay. So by definition, the discounted payback period for a certain given discount rate, it constitutes the time when the NPV becomes equal to zero. Okay. So if we don't have a discount, without discount, we say it's a payback period. Okay. So here's the payback period is 13, and the discounted payback period for 2% is 15 years, and the discounted payback period for the ROI is N, which is the lifetime of the system, which is 20 years. Finally, as we said, to assess the profitability, it's not enough to get a NPV just higher than zero. Because when we did the assessment, we have several risk factors, several issues that we are not aware of. We are reasoning in constant A, which might not be the case. This is why we say that to be on the safe side, we can follow the capital enrichment rate method, which consists on saying that to ensure that we have a profitable project, we have a condition that the ratio of the net present value at the lifetime of the system, NPV at year end, over the initial investment should be higher to 0.3. This means what? This means that my net profit should be at least 30% of the initial investment. Okay, so for each €1 of initial investment, I should gain at the end of my lifetime of my project, I should have €0.3 as gain. Okay, so in theory, the project is profitable when I am just have NPV larger than zero. But as we said, in order to take into account taxes and other costs not included in the NPV computation, it's better to set a certain higher value, which is equal to 30%. So to judge that our project is profitable, we put the condition that the capital enrichment rate, which represents the ratio of NPV at year end over the initial cost, is higher than 0.3. Okay, and this method of analysis is used in several projects. So this is the chapter of economical analysis. And here mainly what is important is to practice. This is why I will post a small assignment. Okay, as usual, and the assignment is just for you to try to practice, and we will correct it together on the date you want. And now we can agree on the group on a date that's convenient for all, to just do a final extra session to practice on the last two chapters, and then we'll be ready for the exam. Any question?
Thank you, Miss.
Welcome. So do we have a group that want to present now?
Yes, actually, I think it's at 8. I will just make sure because there was someone with an exam.
Okay.
I will call him and see if he has finished yet or not.
Look, if you don't want today, you can do it anytime. We have a lot of time. And you can do it tomorrow, after tomorrow, or on Friday. We have the whole day for the presentations. So as you like. In case you are available, tell me, okay?
Okay, so it will be at 8 if we are available.
It can be at 8:30 if you prefer. No, it doesn't matter.
Okay, I will send you a message just to confirm
Okay.
when
Okay.
they are done.
That's fine.
Okay, thank you.
Bye.